In today's lesson, students will examine some of the problems of trying to measure the age of rocks using the process of radiometric decay. They will learn that absolute dating does not mean absolutely proven correct. Have the students add a few drops of food coloring to an empty, clear glass. They should punch a small hole in the bottom of a styrofoam cup, then insert a round toothpick into the small hole. Have them place the styrofoam cup over the clear drinking glass. Now have them gently pour 100 milliliters of water into the styrofoam cup. They should start to see the drops of water come out of the styrofoam cup and drop into the clear glass where it changes color. They should count and record the number of drops that fall in 1 minute. Scientists must know the rate at which radioactive element decays or changes into another daughter element. They must also know the half-life of a radioactive element. This is the time it takes for one half of the radioactive element to change into the daughter element. They can calculate the age of an object containing radioactive elements when this information is available. However, the obvious error in using radiometric dating on Mount St. Helens Dome should cause scientists to be skeptical of claims that rocks are millions of years old. See textbook page 24. They should do this 2 more times to show that the rate at which the water drops is consistent. Note that 71 drops fell in 1 minute. The 100 milliliter of water in a cup represents the total amount of radioactive particles. They should eventually all undergo radioactive decay and change into daughter elements. The actual process of complete radioactive decay in nature is often very long, but the rate of decay remains the same. The students may assume that this process they are observing will continue at the same rate until all the water has fallen through the hole. Observing for a few minutes will be sufficient. They should take 2 more 1-minute readings to show that the rate at which the drops fall is consistent. The rest of the activity will help students understand what is meant by half-life. Have the students pour 50 milliliters of water into a clear glass and mark the level with a rubber band. Scientists only need to know the rate of decay and the time required for 1/2 of the radioactive element to decay to calculate the age of radioactive objects. The students should pour 100 milliliters of water through the cup as before. They should assume that 1/2 of the water will be gone through the opening of the cup and reaches the rubber band marker, but observing for a few minutes is sufficient. They should put food coloring in the clear glass and count the drops of water that fall in a minute. The rate should be the same as before. They should take 2 more 1-minute readings to show that the rate at which the water falls is consistent. Note that the rate at which the water falls is still 71 drops per minute. However, they should know that even with careful measurements, radioactive dating is not always accurate, as shown in the wildly inaccurate calculated age of Mount St. Helens lava dome and other objects of a known age. Scientists still consider radiometric dating a valuable tool, even though there are some potential errors in its use.